Everyone. In this video, we'll be solving another problem from StrataScratch platform. The problem is called risky projects, and this question has been asked in LinkedIn, and this is a medium problem. So the question says we have to identify the projects that are at risk for going over budget. A project is considered to be over budget if the cost of all employees assigned to the project is greater than the budget of the project. Yep, sounds good. Then you will need to prorate the cost of the employees to the duration of the project. For example, if the budget for a project that takes half a year to complete is $10K, then the total half year salary of the employees assigned to the project should not exceed $10K. Yep. Salary is defined on a yearly basis, so be careful how to calculate the salaries for the projects that last less or more than 1 year. So we will be given the yearly salary and we have to prorate the salary according to the tenure of the project. Then we have to output a list of projects that are over budget with their project name, project budget, and prorated total employee expense. And after that, we also have to round it off to the next dollar amount. And they have given us a hint to make it simpler. Consider that all years have 365 days and we don't need to think about leap years. Okay. So let's take a look at the input tables. So we have LinkedIn projects, the project ID, project title, project budget, project start date, end date. Then we have the linked table, LinkedIn employee projects, which is linking the employee ID and with the project ID. Then we have LinkedIn employees. This is the employee ID, employee first name, employee last name, and employee yearly salary. So first of all, let's try to join these three tables and pick up the relevant columns. So let's do a select and let's call this table LinkedIn projects P. So from P table, we want P dot title. We also want P dot budget. We also need start date, and we also need P dot end date. Then we will do a join the second table, LinkedIn employee projects. And let's call this EP. And we will do a join on EP dot project ID. So we will join these two tables on EP.project ID and ID from LinkedIn projects because this is also project ID. So we'll do EP.project ID equal to P.ID. Then we will join the third table, which is called LinkedIn employees. And we will call this E and we will do a join on E.ID with EP.empid. E.ID and EP.empid. Now let's run this. Okay, so there is an error. So what we also want the employee salary. So we will do E dot salary. So now, as you can see, for project one, there are two employees who are allocated to project one. So these two values remain the same because because these are the same projects, right? That's why the budget is same. And start date, end date is also same. But we have two rows because when we did the join, there were two employees who were actually working on this project or who will work on this project. So the next step would be to group these two rows into a single one. How can we do that? So we will do a group by on title. We will take the average of budget, which will come out to be this value only. Then we will do a max of start date. You can also do a min. It doesn't actually matter because these values will remain the same. So you can do either max or min. Similarly, you can do a max or min to get the end date. And to group these two rows, we will do a sum. You're getting my point, right? Why are we doing the sum? Because these two employees are getting allocated to this project, and this is the project budget. So we have to take the sum of these two salaries. So what we will do is we will do a group by title, and we will do the aggregation on rest of the columns. So for budget, we will be taking the average, and we will call this as budget. For start date, we will take the min or max, whatever you want to take, and we will call this as start date. And this is max. Okay, sorry, min. And we will call this as end date. And we will take the sum of salary of both the employees. Now let's run this. So this is the total yearly salary for both the employees. This is the budget for the project one. Now let's calculate the tenure of the project. So let's do one thing. Let's put this into a temp table. Let's call this T1. Now let's calculate the tenure. So select title, budget, how to calculate the tenure. So we'll have to subtract these two dates. And to do that, we have a function called datediff. And what do we want out of this? Do we want year, month, or days? We want days. So we'll write day, then start date, and end date. So these three parameters need to be passed to this datediff function. And we will call this as n underscore tenure. It's tenure project. Or we can call this project tenure. And then salary from T1. So now let's run this again. So this is the project tenure. So the project tenure for project one is 194 days. And this salary is for 365 days. So we have to calculate the prorated expense, right? How can we do that? So let's suppose this is 194. So we have to divide this by 365. And after that, whatever comes out of this, we will multiply with salary. So this is the prorated employee expense or prorated salary, you can call it, for 194 days. So the salary which will come out of this calculation will be the salary for 194 days and not for 365 days. So let's do that as well. So how we are going to do that? This is the project tenure, and now first of all we will multiply this by 1.0 so that we get the answers in decimals. And then we will multiply this by the tenure of the project. And after that, we will divide this by 365. So this is the prorated, and we'll prorated employee expense. Now let's run this. So this is the prorated employee expense. But we have to round it off to, the question says we have to round it to the next dollar amount. So to do that, we will use the ceiling function. We'll use the ceiling function. Now let's run this again. We got this. And now let's put this into another temp table. Let's call this T2. Now we just have to write a simple where condition. Select title, budget, and we want prorated employee expense as well. from T2 where budget is less than prorated employee expense. So let's run this. So these are the risky projects. So let me just run this. Let's check the solution and it passed. So now let me just reiterate some things, some important things actually, which are quite tricky. So first of all, this part. So to group the, so to do the aggregation on title column, so we took the average of period budget. You must know the reason why we did that. So that the budget comes out to be the same. Then we can either take min or max on the start date column and similarly for the end date column. And this is the trickier part. So we have to take the sum of the salary of both the employees. And after that, we just did simple joins. So that is straightforward. After that, we found out the tenure for the particular project, the project tenure, by taking the difference of both the dates, end date and start date, and we got how many days that project will last. And after that, we calculated the prorated employee expense. This is also a good calculation here. So we first of all found out the tenure of the project, divided it by 365, and then multiplied that with the salary of the employees. And to round it off, we took the ceiling because the question said we have to round it off to the next dollar amount. And after that, we just applied the simple where condition to find out the risky projects. So the risky projects are those for which the budget is less than the prorated employee expense. And we got the answer. So I hope you guys understood how we solved this. But still, if you have any doubts or any suggestions, please post them in the comment section and I will try to resolve them. Thank you.